So we're going to take one last look at these properties of limits, and we're going to do it in the context of a graph. So it says, the first one says, what's the limit as x goes to 0 of f of x plus g of x? So notice that when you do the limit of f, it's 1. The limit of g looks to be 1, 2, 3. So this is really using the property of limits we learned earlier on in the year. It would be 1 for the limit of f plus 3 for the limit of g, which would be 4. Pretty easy. Next question is the limit as x approaches -2. So again, look at these separately. When you approach -2 for f, we're at 2. When you approach -2 for g, you're at infinity. So we really have 2 minus infinity, and that's going to turn out to be -infinity. Same type of question, but now we have f of x divided by g of x. So the limit as x approaches -2 of f is still 2. The limit as x approaches -2 of g of x is infinity, as seen by the graph. So 2 for f, infinity for g. And when you get that situation, 2 divided by infinity is going to be 0. The next one. You're going to have to recall how to do a composite function, but basically you do the inside first. So when you have the limit of a composite function, you can just figure out the limit of g first, and then evaluate f at the answer. So as x approaches 0 of g of x, that turns out to be 3. We have to look for f of 3. This is not a limit anymore. This is just looking to the function f, going to 3, and determining what the value is. Now, the value looks like it's about -1 to -2.5. That's not exact, but as close as we can get. The last question is, this is still a composite function. This is 3 to the power of f of x. So you can treat it like a composite function. Do the limit of the inside function, which turns out to be the exponent. So think of this like the limit, or 3 to the limit as x approaches -2 of f of x. Now the limit as x approaches -2 of f of x, got my negative there, is, as we saw before, is 2. So this would just be 3 to the second, or 9. So that's it for that type of question. The next video we're going to talk about limits at infinity, not infinite limits, and what they have to do with horizontal asymptotes.